We have a warm-up right here. So do the antiderivatives of these bad boys right here. Pause the video, attempt it, and then we'll see if you got it right. So for the first one, I'm trying to figure out, because we haven't done antiderivatives yet, or integrals, so you will have a much easier way, but right now I'm just thinking, if I was to take a derivative of an x, what derivative would end up giving me an x to the 6? That would be x to the 7. If I take the derivative of x to the 7, I should end up getting x to the 6. Now, if I was to take the derivative of x to the 7, I multiply by 7. So what number times 7 would give me 9? That would be 9 over 7. And we also don't know whether that's going to be constant, because constants, when you take a derivative of a constant, they go away, which means we're going to have some c or constant that we just don't know what it is yet. The same thing for the next one. I'm trying to figure out the derivative of what would give me cosine, and that would be the derivative of sine. So derivative of sine would give me cosine, and of course I'm going to leave the inside the same. But also, if you were to take the derivative of sine, you would actually multiply by 1/2 because of the chain rule, which is why I also made sure that there's a 2 here. And for the same reason of what I just talked about, you have to have a plus c. So for these ones, I'm going to do it live because they're really easy. So product rule, I'm going to do the derivative of the first thing, so 2x times and then sine of x. And then I'm going to leave the first thing alone. So it's going to be, by the way, big brackets. Because the 3 is just a constant, I'm just going to leave it on the outside. Don't really need to bother with it. And then leave the first thing alone and make that a cosine of x, because the derivative of sine is cosine. And there you have it. Is there anything I can do to make it? I can probably factor out a x, but I'm going to leave it at that. And then for the second one, we take the derivative of the first thing, so 20x to the 4th times cosine of x cubed. I think that's cosine of x cubed. Yeah, if it would have been cosine cubed, it would have been, the 3 would have been right here, but it's not there, so I don't have to worry about it. And then plus, we're going to leave now the first part alone, so 4x to the 5th, and that's how I write my 5, I guess, plus 3 times derivative of cosine of x cubed. That will be negative sine of x cubed times the derivative of the inside, which is 3x squared. Can I make that look nicer? I don't know. Yeah, you probably want to leave it like that. Possibly factor out the negative. Put a negative right here so you don't have to worry about it in here. But there's nothing else I can really think of to make it look nicer. Alrighty, let's move on. You're going to be learning about the quotient rule. So you're going to be taking derivatives of quotients. So here's the rule of it. If you have like two functions, like let's say u on the top and v on the bottom, both being functions that have variables in them, then you would first take the derivative of the top times the bottom, and then minus the top times the derivative of the bottom, and then all over the bottom squared. So pretty much we should end up something like this. I guess the better illustration is right here. So let's move on. Here's an example. So let's do this example. The derivative of the top would just be cosine of 5x times 5 because of chain rule. Let me use a highlighter. I'm really talking without. So that's the derivative of the top times the bottom, and then minus the derivative of the bottom, which is just 8 times the top divided by the bottom squared. Now, what else you could have probably done is just use product rule. If you would have treated it like sine of 5x and then times 8x minus 3 to a negative 1. In this case, you would have just done the derivative of the first thing, which would have been 5 cosine of 5x, and leave the second thing alone, 8x minus 3 to a negative 1, and then you would have been plus, and then sine of 5x times the derivative, which is negative 1 times 8x minus 3 to the negative 2, and then multiply that by the derivative inside, which is 8. Yep, I think I did that correctly. And they should be the same. Let's see if I can make it look prettier. And so here I have it. I kind of made it look nicer. I first factored out a 8x minus 3 to a negative 2 because this looked really bad. And I ended up getting the same thing, essentially the same thing, using product rule. So quotient rule really is product rule. If you don't know what I'm talking about, the 8x minus 3 to the negative 2 is the same thing as just putting like a 8x minus 3 squared on the bottom of this entire thing. But you should see that that is pretty much the same that was achieved up there. Alrighty, is it the same? Yes, it is. Alrighty, good stuff. Alrighty, so that's the quotient rule. Here's another example. So do the derivative of this. So first we're gonna start with the top. The derivative of the top is 7, move to the front. So 7 5x minus 2 to the 6, which is what happened right here, times the derivative inside, which will be 5, and then the bottom would be 4x plus 9 third, and then minus the derivative at the bottom, which is right here. You move the 3 up front, derivative bottom, you move the 3 up front, and then 4x plus 9, that's a squared now, because the 3 minus 1 is 2, times 4, derivative inside, and then times the top, 5x minus 2 to the 7th power, divided by the bottom squared. At that point, you can make it look a little nicer because you want to see if you can have, if you can recognize certain terms. And if you want to go ahead and kind of look at it, pause the video and look at it to see what can be factored out. Now, the stuff that can be factored out is the 5x minus 2. I have 6 right here. I have 7 right here, so we can take out 6. For the 4x plus 9, I have 3, and over here I have 2, so I can take out 2. And then I get the inside looking like this. The bottom looks very similar. I can cancel out 2 from the top and bottom, which leaves me with 4 right here. And that's the simplified version of the quotient rule. Now, try this one out. Now, keep in mind that that's a constant. So we're going to have 0 minus and then 5 times the derivative of bottom divided by the bottom squared, which simplifies to be this right here. That was very easy. And here's some more. I'm going to go ahead and leave these because I don't think any of them stand out. The first one's the product rule, so I don't know why that's there. But then we have this one, so we know how to take the derivative from top and bottom. That one right here is the chain rule. And then this is also not that bad either. Alright, so go ahead and do all of these, and I will check your stuff when you come in class tomorrow. I changed my mind. I do want to do a few of them. So derivative of top would be 4, and then x cubed. I don't know why I wrote like that. Times cosine of x minus, and then, well, it's negative sign, so that's plus, plus sine of x times x to the 4th. That looks really bad. So I can probably factor out some, but I'm not going to. And then we have cosine squared of x. Alrighty, so let's move on to the next one. This one right here is chain rule. So derivative of the top would be 3 sine squared of x times the derivative inside, which is cosine of x. And then we have x cubed, leave the bottom alone, minus 3x squared, and then sine cubed x divided by all that divided by x to the 6th, because x cubed squared is x to the 6th. You can factor out at x squared. I highly recommend factoring stuff out because you can actually get rid of this term right here. You can actually remove this, and you can remove this, so you can already see a net benefit from factoring out x squared. So I would highly recommend you guys doing that. Alrighty, and I think I'm gonna stop right here because that's just a chain rule, a simple one at that, and this one's just a product rule. See you guys tomorrow.